So this is the video lesson for section 1.1, variables and expressions. So to start off, why don't we look at what's in the blue box on page 4 in your textbook. Now, if you read it, consider the population of Florida, the area of Colorado, and the flight time from Philly to San Francisco. Which of these has a value that varies? Explain. Now, when they say vary, right here, they mean what won't stay constant. So no, the area of Colorado will always stay the same. However, some things always won't stay the same, such as maybe the population of Florida or the plane speed from Philly to San Francisco or from San Francisco to Philly. So, which of these certain factors, the population of Florida, area of Colorado, or the flight, which one of these will vary, as in what won't stay the same? Now, if you look at your student companion on the next page, it will explain what quantities are. So quantities are something that can be measured or counted, such as, quantity. Examples are feet, inches, centimeters, anything that can be counted or measured. Now, other words are such as variable. It is a symbol, typically a letter, that represents a value of a variable quantity, such as X, Y, Z. And two more words, algebraic expression. That is a mathematical phrase that includes one or more variables, such as X plus Y or A plus B. And the last word is numerical expression. And that's a mathematical phrase involving numbers and operation symbols, but no variables, such as 3 plus 5 or 2 plus 0. The main thing is expressions do not have equal signs. All right, so let's move into problem 1. So problem 1 asks, what is an algebraic expression for the word phrase? So letter A is, if you look at your paper, 32 more than a number n. So when you see more than a number, that means to add. So the expression would be n plus 32. So you want to write, and you fill in the blank, a plus. All right, and letter B is 58 less a number n. So if it's 52 less than a number n, that 58 less than a number n, that means that from 58 you're going less than n. So it's going to be 58 minus n. So make sure you put your 58 in the blank. So, looking at these two, why don't you try the got it on the bottom of letter B. Once you're done, you can look at problem 2. So it's asking the same thing again. What is an algebraic expression for the word phrase 8 times the number n? Now, when you see the word times, that's going to definitely tell you to multiply. So if it's 8 times the number n, it's going to be 8 times n, which is the same as just writing 8n. If there is no distinct operation sign between a number and a variable, that means that the operation is multiplication. So why don't you write this in your let me undo that. Why don't you write 8n in the blank right there? This whole thing. All right, so letter B is the quotient of a number, n and 5. Now the quotient, as you can see in your word box up there, quotient means divide. It is the number you get dividing two numbers. So the quotient of n and 5, because it's between n and 5, n is first, and then 5 is second. So why don't you fill that into your blank? After you've done that, try the got it letters A and B on your sheet. All right, so moving into problem 3. Now this is where it gets a little bit trickier. What is an algebraic expression for the word phrase? So now we're getting into a little bit more into depth. So letter A, so for 3A, it's the word phrase reads 3 more than twice a number x. So 3 more than twice a number x. So that means that twice a number x, that means that you're going to be doubling. So we got twice the number x, and it's 3 more than. So that means that you're just simply adding 3. Now, because you're going to learn this later, addition is commutative, you can write it either 2x plus 3 or 3 plus 2x. So why don't you make sure 2x goes into your blank. Right, let's try one more of these. So let's try 3b. Okay, this states that 9 less than the quotient of 6 and a number x. So it's going to be 9 less than whatever that quotient is. So the quotient is between 6 and x, and it's going to be 9 less than that. So you're going to have to subtract 9 from it. So make sure these go into your blank. It's going to be 9 less than that quotient. So why don't you try problems 3C and the got it. All right, so after trying the got it, let's move to problem 4. Now, this is where you're going reverse now. You have an expression, and now you want to write the word phrase for it. So we have 3x. Now, what do you notice between the 3 and the x? There's no visible operation sign. So now we know it's multiplication. So you can write this many different ways, but following what the book is, this is going to be 3 times a number x. So why don't you write a number x into those blanks and try the got it. After you've done that, moving on to problem 5, this is asking us, what is the rule for the height? So you're given a table, and you're given how to find the height when there are 2, 3, 4 levels. So now this goes back to the problem we were doing on the first page. Which one of these has a value that varies? So now we want to look at what stays the same and what changes. You can see right here that 3.5 always stays the same, and the 24 stay the same. So the height of the blocks remain the same, and the height of the table will always remain the same. Now what we're looking at is the number of levels that's changing. First is 2. Then it goes to 3, and then it goes to 4. So what do you see that is changing? The number of levels is changing. So how do we think of the rule for the height for n number of levels? Well, if this 2 goes into here, and this 3 goes into right here, and the 4 goes here, we can assume that because of the pattern, that for n levels, it's going to be 3.5 n plus 24. So let me write it on the next slide. N levels is 3.5 times n plus 24. So we'll come back tomorrow and try to got it.